Hello everyone to a new edition of Glamorous Toolkit Live, and today we're going to talk about moldable search. So I'll be joined today again by Andrei Kish, our colleague. Hello, Andrei.
Hello, everybody.
So we'll be talking about search. Search is implemented in an interface that we call Spotter. You can see the icon over here. So right in as you start Glamorous Toolkit, or here on the top right, or you can press Shift-Enter. So if I click on one of these, that's basically the search interface, or the main search interface, or the easy search interface. So what is this search interface? We can search anything. We can search. We look at search as being the entry point into the environment, and so we have here different ways to go in there. So a slideshow is over here, documents maybe at the bottom, or different tools. And another way would be to go to dive into the environment through search. So what can we search for? So here, as we start, we can see tools. This is one category. But as we start, so if we say, okay, here's playground, and I press enter, I go into playground, which basically means that this is also a very easy kind of shortcut. So pressing Shift, Enter, Enter, and then we have a playground. But what else can we search for? So we can also search for something like object. So what happens here is that we get multiple of these searches. So we can search for, we see classes over here, packages, and they all have object in the name. But we also see things like implementers, so methods that have object in the name, or the senders to something like object, or messages, or some other things. So we can have multiple kinds of searches over here, right? So it means that if we press enter here, then we open the coder and we see the object in this case. What else can we search for? We can also search for methods. Let's say we want to search for do. So in this case, we're searching do is it's going to be a message send, a message. And so here we see the implementers of do. And then here we see senders, and then we see messages. So let's see, what is the difference between these? So the implementer, if we go through the implementers, we see here on the right, the actual source code of the method. So here is the method is array2d do colon, and then we see exactly the same thing. We see the method array2d in do, and then we see the source code over here. So what exactly is this here on the right? Well, that's an inspector. So you can also go to see the inspector if you want to here. But this is a full inspector embedded as a search. And because, of course, our search, or because the inspector present the object in meaningful ways, that also makes it an interesting preview to have for the object. This also goes into the compositionality of Glamorous Toolkit. Like we look at Glamorous Toolkit as being a language. So we look at the environment as being a language. What you're seeing here, we are building Spotter out of a composition between the search result and an inspector. Okay, so so this is one thing that we see here. Now, one question that we always get is, what's the difference between implementers over here and messages here at the bottom? So when we look at this, this now is a message when do, and then here are all the methods that implement that message, which means that here we're not just looking at, so here we will have many results for do, so methods that include do column, and there here we see 2,430 such results. But in the messages, we see much less of them. So, okay, now, what else can we see here? So we can also search for things like the file system. So if you do // for example, in this case, I'm going to search for the local file system. And so here I can see the files, or I can see directories over there. Now, what is interesting, what would be interesting here in the case of of searching through files and folders would be that now, given that here we have a folder, would be interesting to actually be able to dive into that folder. And this is where these icons here on the right play a role. So here we can see this icon here says it's dive into this search items details. So what does that mean? Let's do that. So if we go here, what happened was that we have now dived into it and the context of the search has changed. So we are no longer in a global spotter search context. We are now in the context of this specific folder. So we're going to now everything that we are searching now here. Let's say that we want to go into iceberg, right? So the search is now only going to make sense, or only are only showing us the directories because that's the search that works in the context of the file local, which is a directory. So now, and again, here we can go and dive in, and we will see other directories over there. So let's dive in there, and we see some other directories, this is that's basically how we are. We can use this. So there is this notion of diving. So let's do it differently. Let's, for example, go to object, and these are now classes. And if we dive in, we are now diving into the context of that class. And now the searches there are going to only show what is relevant for searching within a class. So what does it mean? Well, here, for example, we see instance methods, methods from the superclass. We can see class methods, class methods from the superclass, variables, but we can also see references. So references to the class object, and so on. So a couple of other such searches over there. So for example, if we want to find the print related methods, we can see, for example, here, this is print on, right? So we can find print on, and then if we go there, then we can see that this is the method that we searched for. So there's this idea that search is not just, on the one hand, is a global entry point, but on the other hand, is not a monolith. It's not something that, it's not just a single step activity. It's an activity that can be refined. And that's the interesting part in the solution that we have for search. So let's see, what can we do with this a little more? So let's say if we are interested in finding out things about Spotter itself. So we can say, I want to search for Spotter, in which case we can see, we will find here packages, or we can find here classes that are named like that. And also here, for example, because we have classes and a class has a comment as a presentation, then we can start to read documentation as well over here. And if it's too small, we can always try to enlarge it and we have a little bit more space for searching, for reading. Okay, so this is one. So we have this idea of that there is no single, we have an entry point, which is global, but as soon as we have an object, we can dive into it, and that object will provide another context, and then we will be able to search within that context. And there is one other thing here. So we can say, if you go back to do, we notice here that there are 2,430 different methods that have do in the name. And so the question there is, how do we see all of it? Because here we only see 5 of them. So this is where we have this notion of a category. So implementers is a category. And here there is a button which says, well, dive in the whole category. And if you dive in the whole category, then the only thing we are seeing are is that category. So now we are diving into the context of the category, and now here we can then refine our search the way we want to. So maybe we're going to say, I want the collection do, right? So now I am going and seeing this specific method, right? So like if I don't have a specific knowledge, and if I want to apply basically an end, right? So when I sit here, let's say, I say do, and I say command, I can also do Command Shift right, and I dive into the category. When I'm now searching for collection do, I am essentially have constructing an end. So it was the previous search and the second one. So it's an intersection. And I have 104 results, right? Then again, like if I want another end, I can go in there and then find something else. So let's say if I want to find how it's this do separated, but I don't know exactly how it is named. Now I've just split my search into 3 little steps. And at the end, I have constructed my, my more complicated search, but without necessarily writing a program, right? So it's a Boolean logic here, but it's not, but without necessarily writing a program. Okay, so one other thing, and maybe the last one, let's say that we are interested in seeing just pragma. So if we say here GT, and if we go at the, if we start scrolling a little bit here, we see that one of the categories is called pragmas. What if we want to see, if we know already that we're going to look for pragmas and we know that there is a category called pragmas, what if, can we, how can we, filter the list that we are seeing just to show us exactly that one? And you notice here that the names of these categories has a hash behind, and that's because we can type that hash in there. So if I say, I just want, if I say just P, now I also have packages and I have pragmas there. And so it shows me both. But if, as soon as I only have one category, then that category is shown in full. So as if I would have dived in it. So here I can see pragmas and I see 44 items of it. So let's go and dive in there and say, well, how is this, how are these extensions, right? Because like what you're seeing here, this, all of these searches, all of these categories are basically following the same principle that the inspector follows. So the inspector says, I don't know how to present an object, but the object can contribute how it wants to be presented. And the inspector, the only thing the inspector does is simply ask the object returns the views, and the inspector displays the views. So when we are now looking at the search, we're applying exactly the same principle. And so now we are saying, the search says, I don't know what I should be searching for, but every object that defines the context knows how it can be searched. And so the only thing that the search interface does, so spotter interface does, is simply asks the object for the searches that should be applied on it. And that is what gets presented here. Now, in the previous, for the inspector, we saw before that we can extend this, we can extend it, the views with GTView. Now, how does, and of course, we will be following a similar principle when we will be, when we are doing it for the search. So how is this one called? So maybe, let's see, oh, there's no spotter there. What about something if I look for search? Oh yeah, there is a search there. So I can see this is a pragma. And if I dive into it now, what do I see? Well, I see here 150 different pragmas that implement the search. So define different kinds of searches. So on top of the 1,000+ views for the inspector, we have 150 out of the box, 150 plugins for the search. So let's go and dive into that one. So if I'm now diving into this category, I'm now seeing here 100 all of this, and I can basically go and browse a little bit. So what we see here on the right is we see the method that defines a search, and it returns, or it accepts kind of a builder step, a step that knows how to construct something we call search processors. And what we are seeing here at this step, we want to define a list processor, and this is a priority. So priority will be, these processors will be competing with each other, and at the moment we have a priority, and the priority will define the order in which they are being presented. And in this case, it's a simple processor, and it simply says, given all these candidates, I want you to filter them by substring. And then there's a match that happens there, and that's it. That's the only thing that is needed here to define a processor. Okay. So the first thing, the first object that we see here on the left, right? If we want to say how many or what kind of searches are there available, the first object that we start spotter on is called GT spotter start, and that's a method. Sorry, it's a class, and we can see here there are 27 searches defined out of the box on that class. So here we have the actual search for the pragmas. So this is when we search here for pragmas, this is how this processor is being defined. So we have the list processor over here. Pragma type all will return us all the pragmas in the system, and we're gonna filter by substring, and that's it. That's all that there is there for the search. So this is a short summary of how the interface works. Andrei, what did we miss? Did we miss anything?
No, but yeah, we looked at, yeah, that's the basic interface.
So what else can we do with it? What do you think? Or what would you say that we should show?
Well, we can look at maybe more, till now we just looked at code. So we looked at things that were specific to code. Maybe it's more interesting to take some kind of domain object and see how.
Do you have a suggestion for that?
We used before in some previous, in a previous session with the address book example.
The address book example.
To show,
so let's search for it. You're saying address book example. This one.
Example, exactly.
So this is an example class, and now ideally we should go and find.
Maybe we can search for the category. Examples. So filter by category, or
here.
In the other one, to show just the address book.
Just the address book, or maybe we see it here.
Yes.
Address book, this one. This one?
Looks good.
My contacts address book.
Yes.
So basically here we needed to find the top search, the top example. And this is where the map of examples is useful for. So for those that maybe were not here, for an example is like a test. So here we see a setup, we see the search. But the only difference there between an example and a test is that the example returns an object. Because it returns an object, not only can we use it for running and executing, we can also use it for actually playing with it. So here I have just run this example, and I see here that it adds 1, 2, 3, 4, 5 contacts. Is that correct? Yeah, I think, oh yeah, I can see here this is equals 5. So I see here, okay, it is John Doe, and I guess this will be Jane Doe, yeah, and so on. Okay, so okay, we have, and then if I inspect the result, I see here 1, 2, 3, 4, 5 contacts. That's what you wanted to see, right, Andrei?
Yes. So now we have some kind of a domain object, more specific domain object, not just the code that we were looking at before.
Right. And so now we should be looking at, we wanted to look at the search. So this is now an inspector. And what is interesting here is that now we have here a search button that I see here. So this search button is actually added automatically as soon as the object here defines a search. So if there exists a contextual search for this object, boom, it appears over here. So let's see, if we now look at that one, I can see that there is a contextual search here. So I can, if I search for Doe, I can see that John Doe and Jane Doe are both here. Right, that's very nice. So this is here, here we're having a contextual search right in place. And the other interesting thing, I think here, I think I saw here that one of these probably has a little bit more. So if you look here in Burn, and if I dive into it, yes, I can see that the address object over here now has 2 people. So it also defines it another search. And so now I can maybe search for John, and I will only see John, or Jane, I will only see Jane. So essentially here is a very simple, so there's a generic interface, and customized in very simple ways, it can be used for producing contextual searches. Should we look into how it's implemented, I think?
Oh yes, would be nice to see
so
how
we're
those
looking
searches are implemented for this object.
Right. Yeah, so here we have the GD address book. And so to look at the implementation, I will switch to the meta tab, which shows me the class of the object that I'm looking at. And you can see here that there are some spotter searches. So let's look at the one for addresses. I can see, okay, so this is a block that returns, that specifies, I want to see, given that I already have the address book, self contacts, if I'm executing that one. So I'm inspecting the result of self contacts. So self exists because I'm in the context of an object. You can say self contacts, and I can see, okay, this is what this, these are what the contacts are. This is the collection in there. And if I do it like this, it gives me, right, so the way it finds all the addresses is basically by looking at all the contacts and collecting the address from each of them, right? So if we search this, and we see here Berlin, France, Paris, France, Bern, Switzerland, and New York, USA. So nice. And then here we say we can match multiple substrings in this case. And okay, we also see that we're showing a candidates limit up to 7. And that this is what we want the print string to be. So the city, comma, the country. And that's it. That's the definition for that. So what is now maybe more interesting would be to see, okay, now given that I have this address over here, and I go to Burn, now Burn has also an implementation, and I can see that it has a search for people. So another small method over here. And now we can say that we're searching for people. In this case, this is an interesting case I see here, because it doesn't take the value from itself. So notice how when we go here, when we are just looking at the address book, we don't see a search here. Why? Because the address book doesn't know where it comes from. It only knows city and country. And but we still would like to search for all the people that are available in the address book. But notice how when we were in the address book over here in the address book object, and we search for something like Burn, and I go into that one, there is a search. Why? Because of the context. So the code here on the right says that only if I have if the previous step is the address book, only then will I show something. And what will I show? So here, when I'm seeing all the candidates, I will be showing the contacts with the address from the object that was there, the previous step. So if I look at the implementers of contact with address, I see that it's implemented in GTAB address book, and simply does select over the contacts that match the address. So that's an interesting case, I think, because it shows that the context that we pass in can be utilized for creating more live interfaces. Okay, I think that's a nice summary.
Yes.
So one thing that we could maybe look at would be to start to see how do we combine this. So this is now we have a way of searching, but there are sometimes you want to have a little bit more control over over searches. So here we are having these methods which are annotated with GT search. And there is another way of searching, which is through an actual query. So that way is, if I go into Playground and I'm saying here, let's say that I want to find out all the methods that are annotated with GT search, so to define a contextual search. I'll say I want to find all the pragmas of that. So this is a symbol, and now this is the pragmas. And so when I execute that, I'll see the list of all the possible searches that I'm having. And here we can also, if we take a close look at the metrics we have here, we have 151 methods annotated with GT search, and there are 1,476 lines of code in total. So the average is less than 10 lines of code. So the idea again here is that that's that principle of moldability, in which the extensions to the tools, once they are very, very small, we can produce a much richer kind of an environment. And we can contextualize it for ideally all of our objects. Okay, so now, here we're saying, well, I want to find, let's say that we are interested in finding out what kind of things are there. So I see here, that there is a query or a question on Discord about whether there are other tools than a list processor. So we can take a look at that. So here, right, when we are having this, we have full programmability there. So as opposed to Spotter, there is a full programmability support here in the playground. So here we could say, and we want to find only the list processor. But in this case, we're going to say those that are referencing the list processor. So what this one says is, I want to find all the methods that are annotated with GT pragmas and that are sending a list processor. Ooh, list processor. So what I see here, okay, I see exactly that, right? I see these methods that are defined like that. Now, what if is there something else that is not defined as a list processor? And here is the place where we could go and search for it, for these kinds of non-search processor implementers, except that some of these are actually more complicated. So here, for example, we are just having a search that is delegated to another search. So if we go and look for that one, we'll see here in the compiled method that at the end of the day, it's still going to be a list processor. The only question here is, what will the input to that list processor be? Because the list processor simply says, I want the result to be shown as a list. And then there are other different ways of looking inside the list processor. So defining, how do I find the candidates? Here, for example, we are saying, I want a very specific collection. That's exactly what we've done for the address book. But sometimes there are other possibilities to define a more fluent way of finding like a stream. So basically iterating over maybe a larger structure without necessarily constructing a whole collection, an intermediary collection, and producing the results through while iterating, basically. Okay, so okay, now back to this query over here. What we are seeing is that this is a more complicated one because we now have end, and we have at least here we could see one of the on the left hand side we have the pragmas, on the right hand side we have the references. So and we also have the not. Essentially here, when we are looking at this, is reasonably complicated search. So let's say if we just want to find, for example, those at that is in the class called GT spotter search, spotter start, and we want to say I want those that match this class. Now I'm going to see only the search categories that are in spotter start in this case. Okay.
Coming back to the question, yes, in for spotter only the list processor is currently available as a search.
Exactly, only this list processor. However, this is a case in which we're going in a little step deeper, in which we do not provide necessarily all the like a collection. So we don't wait for the construction of a collection to be produced and then to select from it. But in this case, with a different way of specifying how the search works, we are defining essentially an iterator that goes through a specific has a way of traversing, and it populates the result through this. So we can see here that filter is being passed, and when you do something with it, then you go and directly add results to it. But this is more an advanced solution for it. So yeah, so these are two different ways of looking at search. On the one hand, we have spotter, and spotter is contextualized with these GT search pragmas that appear in that appear in search, and it appeared in context. And on the other hand, we have these more elaborate types of searches that with which we can construct more elaborate queries, more fine-grained queries, and through that we can find source code. Usually, this is just applied to source code. Not only, but by default, we're mostly applying it for source code. Okay, did we cover everything, Andre?
Yes, but maybe we could also implement a search.
A search for spotter.
Yes, a spotter search.
Would you have an idea for which one?
So last time we talked about to-dos. We had a to-do API.
Yes.
That we are using to get the to-dos from a certain API. I think it was a to-do, yeah, the JSON one.
Let's go, and I think there is okay, we look at the slideshow over here. And this one already has examples.
But now, yeah, this one, before we created the code by hand, now we already have a client for that API.
Right, and this one here, for example, we're saying, these are all the to-dos. Give me all the to-dos. And here we get an object. In this case, is a to-dos group. And we could either, for example, here search for, if we now click on user, what happened, right? There was another REST API call that got the data for the user. Now we get the user, and now we get to navigate this user. So one option here could be to add a search to the user.
Yes, to search to the to-dos of that user.
Okay, so let's do that. So I'm going to go to the Meta tab. And just like here, we have the list of to-dos, right? So from this view over here, we can also, it's an interesting thing. So we can also learn about our object by actually looking at how the views are implemented. Because usually views they have these very interesting queries that say, what is interesting from that object? And views give you an interest or nice entry points into this conversation. So we can see, okay, I can ask for these self to-do groups. So let's go and create a new method. And I'm going to go now back and I'm going to search here for just that. And I'm just going to take the first example that I see. I can see here, this is a list processor with all candidates, the item name. So the thing that appears in the label, that it can be filtered. So I'm just going to copy this. And I'm switching now back to our method. And I paste it in. So we can call this GT spotter to-dos. Given a step. And I'm going to annotate the method with GT search. And then here we're going to say to-dos.
Yes, all candidates we need to change. I guess it was.
Right. So as I say, well, self. And here, if we look into the to-dos list, how it is implemented, there is this to-dos group. So we can take that one. I guess that here we can just say display string for now. We will see. I'll actually take a look at this now. So if we execute this one, gives us a to-dos group, and one of these.
Do we have an iterator on the to-dos group?
I don't think so. But so let's see if I have a. Yeah, which maybe should convert it to the to-dos. So, but here we are saying, okay, we have the title. So how is this title obtained? So if you now go into the alt click here, I like the title. So essentially, if we send title to one single to-do, that's basically what we want. Let's see what we have here. So I'm now going to go back into the to-do user, and I will say here that I want, for each to-do, I want the title. Okay, so we were saying if this one is maybe good enough. So let's see if we are inspecting the to-dos group. The question is if this one knows how to be iterated, and apparently it doesn't. So, and this all candidates expects a full collection. So rather than just the to-dos group, we're going to actually take the to-dos. So just a collection from it. So if I inspect that one, I will see actually I have an array here with the 20 items, and that's great. That's exactly what I care.
Yes, super.
So that looks good. And if I save this, what happens is that when I'm inspecting it again, a new icon appears on the left. So I can see the details of here for this user. And there's a new icon here that appears on the top right. And if I look at it, I have my search for to-dos. So let's see what is it. Laborism. Yeah, so these are the to-dos that we have for that specific user. Nice. Let's turn it to questions now. Let's see if there are other questions from the audience. There is a question from Conrad saying, can we access the context also from the inspector? And the question is yes, we can do that. And the way that one works is that you get the second argument with with that context. So if you define a view with 2 arguments, then you get that you get the context in the second argument. Are there other questions? Okay, then we will leave it at that. Thank you very much and see you next time.